Assalamualaikum warahmatullahi wabarakatuh. We are from group 1 and for our group assignment we choose topic line integral. Okay, the team member for our group project is Muhammad Ani Ali bin Azwan and myself Muhammad Aikal Haris bin Muhammad Noor and Ahmad Arif Hakimi bin Ismail and lastly Muhammad Haziq bin Muhammad Syazhan. Okay, for the introduction our group project I will pass to Muhammad Ani.
Hello everyone. Today we are going to explore a fascinating concept from vector calculus known as the line integral. This mathematical tool allows us to integrate function, either scalar or vector, along a specific path in a vector field. It's key for understanding complex phenomena in physics and engineering, like calculating work, circulation, or flux along the curve. This type of integral is special because it not just at a point, but along a specific curve within a coordinate system. Whether it's a scalar vector or a vector value function, the line integral is all about accumulating the field values at numerous points along this curve. This process not only provides a deeper understanding of complex mathematical functions, but also serves as a crucial tool in the various scientific and engineering applications. Let's begin with the concept of a line integral for calculating area. In two dimensions, you can find the area under a function fxy by solving a line integral, as this integral takes the form of the area A is equal to the integral from A to B of the function f evaluated at point xt yt multiplied by the square of the derivative of t with respect to x plus the square of derivative of t with respect to y, all with respect to t. In three dimensions, we extend this idea into 3D space, and the formula becomes the area is equal to the integral from a to b of the function f evaluated at the point of xt, yt, and zt, multiplied by the square of derivative of t with respect to x, plus the square of derivative of t with respect to y, and also plus the square of derivative of t with respect to z, or with respect to t. Now, for our project, we are interested in line integral over vector functions. This introduced a new formula. We calculate the integral from a to b of the vector function f of r of t dotted with r of t with respect of t. One of the most significant application of line integral in physics is calculating work done by a force field. F on a moving project along a curve C, this work denoted as W. We determine the work of W as the line integral of vector field F dotted with dr along the curve C. Dr is the unit tangent vector and F is the vector field acting on the object. Moving on to question 1, which is evaluate the integration of along the curve f dot dr, where fxy equal to x squared minus y squared I plus 2xyj, and C be a curve represented by a circle where x squared plus y squared equal to 4 from 2, 0 to negative 2, 0 as in the figure on the right. Step 1, we identify the x and y, which is in our case, x equal to 2 cos t and y equal to 2 sin t. And we will get our rt equal to 2 cos t I plus 2 sin t j. And the range of t will be 0 until pi. So step 2, we will differentiate our rt, which is rt equal to 2 cos t I plus 2 sin t j. And we will get r prime t, which is equal to negative 2 sin t plus 2 cos t j. Moving on to step 3, we have to substitute x and y into fxy, which is our fxy is x squared minus y squared I plus 2xyj. And we're gonna get ft, which is equal to 4 cos 2t I plus 4 sin 2tj. Moving on to step 4, we're gonna calculate the integral along the curve f dot dr, which in our case will be integration of 0 until pi ft dot r prime t dt. So we're gonna get the last simplification, which is equal to integration of 0 until pi 8 sine t dt. After we integrate, we're gonna get the answer will be equal to 16.
Assalamualaikum, my name is Muhammad Haziq. So now I will explain how we solve question 1 by using maple command. So from the question, we have to evaluate the work done where the force field is x square minus y square I plus 2xyj, and C be a curve represented by part of circle where x square plus y square is 4 from the interval of 2, 0 to negative 2, 0 as in the figure shown below. So now for the solution of the question using maple, so step 1, we must use the command which is restart with vector calculus and also with plots. Next, after we compute the command in step 1, we can proceed to step 2, which is we choose the variable f for our force field and then put the equation given, and then we get the first graph, and then we put implicit plot and the equation for the circle to get the circle. So the final step in solving the question using maple command is to compute all the information gathered and use it in maple software. So first, we use the variable of r equal to 2 cos t and 2 sin t. Next, we must differentiate r. So we use the command diff rt, which is to differentiate r respect to t, and then we get the answer. Next, to find the vector field, we must substitute x to 2 cos t and y to 2 sin t. And then for the answer, we use dot product of vector field and the derivative of r. So we get the answer as shown. For the final answer, we must integrate the answer respect to t to find the work done. So we use the integral of 0 to pi, which is the interval, and then answer respect to t. So after we integrate using maple software, we get the answer is 16.
Okay, now for question 2. For question 2 is, let C be a curve described by C vector r of t equal to 3t square I minus 5j for 1 less or equal than t and t less or equal than 2. We must evaluate integrate vector f dot dr where vector f of xy equal to x cubed I minus 2yj. And we also can see from the figure is the graph for the equation C vector r of t. Okay, for solution by manual calculation, for step 1, we must differentiate vector r of t and we will get 60 vector 60 and 0. And for step 2, we substitute rt into our vector f or sy and we will get 27 t power of 6 and 10. Okay, for step 3, we must determine the dot product from final answer step 1 and step 2, which is vector 27 t power 6 and 10 dot vector 60 and 0. So we will get final answer which is 162 t power 7. Okay, for the last step for question 2, we must calculate integrate vector f dot dr. So we just integrate final answer from step 3, which is 162 t power 7, and we integrate like usually. So we will get last answer which is 20,655 over 4. Okay, that's all from me.
Okay, we proceed to our video to second question or to our maple command. Okay, for the second question for our maple section is quite the same as the first question. As usual, we use the step 1 by using maple command restart to restart our program that we have used before. Second step is we use command with vector calculus because we will want to calculate the vector calculus. Third step is command with plots, so because we want to plots the graph, and the fourth step is we run for each command. Next step is step 5 if we use the command f equals to x cubed minus 2y. We use this to, and our next command is fill plot so that the equation will show his plot. Next step is step 6. We use the command y equal to t squared minus 5 minus 1 over 2 t squared, the same as our question, and we use fit smart plot to show the plot of the equation. Okay, last step is we use the command as shown in the table beside me, such as r t 3t squared minus 5, and we differentiate it and we use vector fill and the command answer to get the answer, and the answer we get is 20,655 over 4. Okay, that's all from us. I hope you guys get something from our video and some useful content that you will use in the future. I hope you guys understand, and thank you for watching until the end. Thank you.